This is Lesson 5-2A from your Algebra Readiness textbook. For today's lesson, you'll need a sharpened pencil in your notes packet. Begin these 3 problems in the study guide. Pause the video and come on back when you're ready to compare your answers with mine. I'm asked to find the least common multiple. To find the least common multiple, I first begin by making a factor tree. 11 is already prime, so I don't need to make a factor tree. So 11c d squared f. 12, on the other hand, I need to simplify or break it down. 4 times 3, 3 is prime. 2 times 2 is the same as 4, and those now 2 and 2 are prime. 2 squared times 3 times c times d. To find the least common multiple, I look at both lists of prime factors. I note each base once, and I select the base with the highest power. Here I've got 11. There is only one 11, so 11 is my answer, or is the one I'll use. Then I have 2 squared. There is no other 2, so 2 squared it is. Then I have 3. There is no other 3. There's no 3 squared or no 3 to the third or anything like that, so I need to use the 3. Then I do the same thing with my variables. I have c and c. They're equal, same power, so just c. Then I have d squared, or d to the second power, and d. D squared is the higher power, so I select d squared. F is alone, so f. Then I do the math. What is 2 times 2 is 4. 4 times 11 is 44. 44 times 3 is 132. C, d to the second, f is my least common multiple, right? For these, let's change the color here so you can maybe see it better. 28 is the same as 4 times 7. 7 is prime. 2 and 2 are prime. 2 squared times 7, xy squared. 42. 7 times 6. 6 is the same as 2 times 3. So 2 times 3 times 7. And then my variables, x squared times y. My least common multiple being, I have a 2 squared and a 2. 2 squared is a higher power, so I use that. I have 7 and 7. They are equal, so I use 7. And then the other number I missed was 3. There's only one 3. X and x squared is the higher power. Y squared and y squared is the highest power. Then I do the math. 2 squared is 4. 4 times 7 is 28. 28 times 3 is 84. 84 x squared y squared is the least common multiple of these 2 expressions. Now, you have also done least common multiple in, let's see, can I erase something here? When it's just numbers and there are no variables. You could list all of the multiples of each number or do a factor tree. I'm going to quickly throw down a factor tree here. Okay, and then in comparing my prime factorization, I see that my least common multiple is 2 squared, oh no, not 2 squared, 2 to the 4th is the higher power than 2 squared. And then I've got 3 and 3 squared. 3 to the second power is higher. So 2 to the 4th power is 16, and 3 to the second power is 9. 16 times 9 is 144, is the least common multiple of 9, 12, and 16. Today's learning target is to convert fractions to decimals. First, let's write down some definitions. A terminating decimal. A terminating decimal when the division of a numerator by the denominator ends with a remainder of 0. So it ends. This is the important part right here. See that? There's a remainder of 0. Pause the video if you need more time to write. A repeating decimal. The same block of digits in the decimal repeats an infinite number of times. For example, we know that when I have a repeating 3, where I get 3, 3, 3, 3, and it goes on forever, that 3 is repeating, that is a repeating decimal. This is always also written with a bar above only the digits that are repeating. Notice I didn't put that bar above the 0 or above the decimal, only above the 3 because the 3 is what's repeating. All right, so the first thing that you need to do is change fractions to decimals. To change fractions to decimals, you simply divide. The numerator by the denominator. Now, 1 divided by 4. This is the numerator. The numerator goes under the fraction bar. I can't take 1 divided by 4, so I need to add a decimal. 10 divided by 4 is 2. Add a 0, bring it down. 4 goes into 20 5 times. Now, I always get people who say, well, I knew that one in my head. If I have it memorized, is that okay? Of course. So I know that 1/4 is the same as 25 hundredths. Do you know that there's other students who also look at this and say, can I say 1/4? I know that if I multiply this by 25 over 25, that I get 25 over 100. And 25 100ths is the same as 25 hundredths, like this, where this is in the hundredths place. This is also an excellent strategy. There's definitely more than one way to solve these. 3 3/10 is my next problem. Now, when you're multiplying, you don't multiply the whole number. You only focus on the fraction. 3 divided by 10. 10 goes into 3, it doesn't. 10 goes into 30 3 times. And I get 3/10. But don't forget about the 3 over here. So I get 3 3/10. Again, using the strategy of, I see that this is 3/10, and I know where the 10ths place is. The 10ths place is the first place after the decimal. And so 3 3/10 is equivalent, and I didn't even have to do any division for that. The next problem, 3/5. I put the 3 under the division bar, divided by 5. 5 goes into 3, it doesn't. 5 goes into 30 6 times. I subtract, and I get 6/10. Again, some people like to look at that and say, oh, 3/5. Well, if I take that times 2 over 2, I get 6/10. Isn't 6/10 the same as putting a 6 in the 10ths place? 6/10 as a decimal? You bet. 1 7/8. Remember, leave that 1 alone for now. Some people like to write it down right away so they don't forget about it. 8 does not go into 7. 8 does go into 70. 8 times 9 is 72, so that's too big. Let's go with 64. 8 goes into 60 7 times, that's 56. Add a 0, that's a 40. I'm losing space here. It's 875 thousandths, 1.875. All right, so that one wasn't as easy because 8 times something didn't give you a 10, a 100, or a 1,000 in order to put it in that place. All right, try this one. Pause the video and come on back after you've tried, wait a minute, did I move? Yeah, after you've tried these two. Oh, you know what? I think we skipped those. We're going to move on. Here we go. These are the ones. Pause the video and try these 3. Come on back. Make sure that if any of it repeats, that you use a bar to indicate the block of digits that are repeating. All right, compare your answers to mine, and let's move on. Reading a decimal correctly provides a way to write the fraction. If your decimal reads 43 hundredths, then your fraction is 43 over 100. This is the reverse of what I was saying earlier. So now I'm going to give you the decimal instead of giving you the fraction, and I'm going to ask you to convert it to fraction form. It's super easy when you read the number. If a decimal is greater than 1, you can write it as a mixed number. So changing decimals to fractions. Number 1, you'll want to write these down in your notes. Identify the place value of the last digit. Step 2, put the decimal portion over that place value, over the numerical place value. And then step 3, simplify. As an example, 1 and 12 hundredths. The 12 is the last digit. The place value of the last digit is the hundredths place. So I am going to use hundredths as my denominator, and my numerator is going to be the decimal portion. So 12. The 1 is my whole number out in front. Then I need to simplify. 12 and 100 are both divisible by, let's go with 4. Some of you might have chosen 2, and that's okay too. 100 divided by 4 is 25, but you would have just had a little bit more work to do. So 1 and 3/25. Pause the video and try these 3 problems. Come on back to compare your answers to mine. In the first one, 1 and 75 hundredths, I get 1 and 75 over 100 because the 5 is in the hundredths place. When I reduce it, I divide both the numerator and the denominator by 25. And I'm left with 3/4, and the 1, the whole number, stays the same out in front. For the next one, 2 and 32, again hundredths. Then I can divide both the numerator and the denominator. Let's try dividing by 4. Over 4 equals 2. 32 divided by 4 is 8. 100 divided by 4 is 25. The last one, letter C, 65 over 100, because the 5 is in the hundredths place. I can divide both the numerator and the denominator by, 5 might be my best bet. And I get 13 over 20. 13/20 is the simplified version of that. All right, so this is all fine and well until we come to a repeating decimal. When you have a repeating decimal, we have a different process. When you have a repeating decimal, write these in your notes. The first thing you're going to do is identify the number of repeating digits. Then I want you to place the repeating digits in the numerator. Step 3, use a denominator of 9, 99, 999, or 9,999. Whichever number has the same amount of nines as the repeating digits. Then simplify. For example, if I have 3/10 repeating, I simply identify the repeating digits. That's a 3. Step 2, place the repeating digit in the numerator. In the denominator, use the same number of nines as there are repeating digits. There is only one 3, and that 3 is being repeated, so I am going to use 1 9. Now I simplify. 3 divided by 3 is 1. 9 divided by 3 is 3. 1/3 is equivalent to 1/3 or 3/10 repeating. Now, a side note, this only works if all of the digits after the decimal repeat. It won't work on something like 0 and 1500ths, where only the 5 of the 1500ths is repeating. It will work if you have 0 and 1500ths like this. It won't work if it's like this. You will not, doing problems like this is above the 7th and 8th grade standards, so you will not encounter any of those. You will only encounter ones that this will work for. But I just want you to be aware. All right, so let's do this one together. The fraction is 72 hundredths. I see that 72 hundredths, the 7 and the 2 are repeating because it has this bar over the top. The steps tell me to identify the repeating digits, 7 and 2. Then place the repeating digits in the numerator, 72 over, and in the denominator, use the same amount of nines as there are repeating digits. There are 2 repeating digits, so I put it over 99. Then simplify. 72 and 99 have a common factor of 9, and I get 8/11. If you typed 8 divided by 11 into your calculator, you would get 72 hundredths repeating. Pause the video, try these 3, then come on back to compare your answers to mine. Hopefully, you, for the first one, you got 7 as the repeating digit, so 7 over 9, and it's already simplified. For letter B, 54 over 99. 54 and 99 have a common factor of 9 for sure. So let's divide both the numerator and the denominator by 9, and we get 6/11. The last one, 213. All 3 of those digits are repeating, so I put it over 999. Then I need to reduce it. When I take the sum of 213, it equals 6. So I know that they're both divisible by 3 for one option. 213 divided by 3 is 71. 999 divided by 3 is 333.